Alright, guys, today we'll be learning how to solve implicit differentiation. So, solving implicit differentiation is not like is the same thing like the normal one, but in this case, we having y, right? We're having y, and now there's a rule for when you're having y in differentiation. So, in implicit differentiation, anytime you differentiate y, right? Anytime you differentiate y, you attach dy dx to it. Once you differentiate y, attach dy dx to the back, and x just goes the normal way without any dy dx. But anytime you differentiate y, you must attach dy dx to the back. Now this is it. You're having y cube plus x cube plus x square plus 2y square. Now let's differentiate this. Differentiating y cube, 3 times y is 3y. 3 minus 1, 2. You know your normal differentiation. dy dx. Hope that's understood. Once you differentiate y, you add dy dx plus differentiate x, 3x square. Differentiating x is 3 times x, 3x minus 1 from the 3. That's why we have a square. Then plus differentiate x again, 2 times x, 2x, 2 minus 1, 1. So no need to write the power here. Hope it's clear. Plus differentiate y, 2 times 2 is 4. So this is 4y, 2 minus 1 is 1. So no need to write the 1 because already goes to the power of 1. Then now remember that when you differentiate y, you attach dy dx. Now moving further, now let's collect like terms. Now 3y square dy dx plus 4y dy dx plus 3x squared plus 2x equals to 0. Right? Now, you move the elements without dy dx to the right hand side and keep the elements with dy dx where they are, which is at the left hand side. So now, doing that, we have 3y squared dy dx plus 4y dy dx will now be equals to, now you are moving these two elements that are without dy dx to the right hand side. We want to isolate this dy dx. That's what we are trying to achieve. So when we move them, we have minus 3x squared minus 2x, right? Minus 3x squared minus 2x. Now moving forward, now like I said, we are trying to isolate this dy dx, right? So as we are trying to isolate this dy dx, what should we do rather to make this dy dx stand alone? That's the moment for you to think now. Now we think, what are we going to do that will make this dy dx, the two of them, to stand alone without all these coefficients? Now if you think carefully and if you understand mathematics carefully, you know that what you have to do is to factorize. Now if you factorize this left hand side, you are going to have dy dx standing on its own. Now let's do that. Yeah, let's factorize this dy dx. Now what's common between 3y squared dy dx and 4y dy dx? What's common? Dy dx. So dy dx is common. So what we do, dy the x outside the brackets, divide the x into 3y squared, divide the x, we'll have 3y squared. Divide the x into 4y, divide the x, plus 4y. Now, if you open this bracket, if you divide x times this, it will give us this. If you divide x times this, it will give us. So this is the same thing as this. Then remember here, minus 3x squared minus 2x. Now, moving forward, we need to make this divide the x stand alone because they say find divide the x. Said we should find what? Divide the x. So we need to make this thing stand alone. So how are we going to do that? We'll divide both sides by the coefficient of divide the x. So what's the coefficient of divide the x? 3y squared plus 4y. So now we'll divide both sides by 3y squared plus 4y. Now we have dy dx 3y squared plus 4y all over 3y squared plus 4y. It's going to cancel out, equals to minus 3x squared minus 2x all over 3y squared plus 4y. Right? So now we are left with dy dx equals to minus 3x squared minus 2x all over 3y squared plus 4y. We can reduce this, 3 cancel out, 4 here will remain 2, 2 here 1. Now we are left with dy dx equals to minus x squared minus x all over y squared plus 2y. So in solving implicit differentiation, let's go through it again. Solving implicit differentiation, what you do first is that you note that anytime you differentiate y, the y component, you have dy dx attached to it. So you differentiated y, and we had 3y squared. And don't forget how to differentiate, it's very easy. Differentiating this, right? What you do is this 3 times the coefficient of y. What's the coefficient of y? 1. Is invisible, we cannot see it. So 3 times that one is 3 times y. Then you now do times y raised to the power of 3. What you now do is minus 1 from this power. So you are now having 3y or square. That's basically it. So what you are not doing, okay, hold on. What you are not doing is when you differentiate this, you get this. Then you attach dy dx to this. Then differentiate x cubed, you get 3x squared. You differentiate x squared, you get 2x. Differentiate 2y squared, you have 4y. Then you attach dy dx again. Right? So you now have 3y squared divide the x. Since you're collecting like terms, plus 4y divide the x plus 3x squared plus 2x equals to 0. Now don't forget that they said we should find what? Divide the x. So what you now do is you factorize the left hand side. When you factorize this left hand side, you get dy dx into 3x squared plus 4y. Then you divide both sides by it. Now you're having dy dx standing alone. So that's it for solving implicit differentiation. Let's do more examples so that you understand the concept better. Now, coming to another example, this is another example. So we want to solve for what? Find dy dx. So that's what we are finding, right? So they said we should find that, sorry. So they said we should find dy dx. What are we going to do about that? Firstly, we remember that when we differentiate y, we add dy dx to the back. And having x is normal. So let's begin. If we differentiate y, 3 times 3 is 9. So we're having 9y, 3 minus 1 is 2, plus 1 times 4 is 4, 1 minus 1 is 0. So y is going to disappear, plus 6x squared plus 8x equals to 0. Now we're having it like this. What are we going to do here now? What we want to do is, oh, sorry, I made a mistake. 9y squared dy dx plus 4 dy x plus 6x squared plus 8x equals to 0. I omitted the dy dx. So now, what we are going to do now, since we already have them together, we just move the x term to the right hand side. So we'll now be left with 9y squared dy dx plus 4 dy x equals to minus 6x squared minus 8x. When we have this, the next thing we do is to factorize, like we did in the last example. You factorize, then let's divide the x be on its own. So if we factorize this, what are we having? We bring out dy dx. Dy dx into this is 9y squared. Dy dx into 4 is plus 4 equals minus 6x squared minus 8x. Now we are left with this. This is the last stage. The next thing you are doing is to divide both sides by the coefficient of dy dx. By dividing both sides by the coefficient of dy dx, what do we have? Divide this 9y squared plus 4. You cancel out. You come here again. 9y squared plus 4. What are we left with? Dy all over the x is equals to minus 6x minus 8x all over 9 squared plus 4. Now you can leave your answer like this. You can choose to reduce to the lowest term, but it's more advisable to reduce to the lowest term. But here I'm just stopping it here. But if you want to reduce, you can still reduce. 3 can go here, 4 can go here. Sure, you get me? So that's it for implicit differentiation. And please don't forget to like and share and also subscribe. Thank you and see you in next video.